Alright, so in this video I'm wanting to show you how to solve a system of equations algebraically. Okay, so we're not going to graph it to just see where these two lines are intersecting. We'll actually do the math. Okay, so the idea is that both of these things are set equal to y, so what we can do is set them equal to each other. Okay, if 3x minus 4 is equal to y and x plus 6 is equal to y, then there must be some value, right? They must be equal to each other somewhere. And now we can just solve this like we used to. I've got an equation with variables on both sides. So I'm going to move my x to one side. I'll move all my x's onto one side of the equation. And then my regular numbers, I'm going to move to the other side. Okay, so I subtract x, and then I'm going to add 4 to move my regular numbers to the other side. All right, the 4's cancel, the x's cancel. I'm left with 2x is equal to 6 plus 4, 10. Divide by 2. That means that x is equal to 5. Awesome. So that's the x value where they cross. And then what we'll do is we'll take this answer and plug it back into one of those equations to figure out what y equals. Okay. If I use that bottom one, it's just y equals 5 plus 6. And so I get y is equal to 11. All right, so these two lines, they're going to intersect at 5, 11. This is my actual solution. All right. If you want to, I plugged it into that bottom equation once I figured out what x is, but I could also stick it into that top equation and get the same answer. 3 times 5 is 15, and then 15 minus 4, that's also 11. Okay. All right, this one. Again, since they're both in slope-intercept form, they're both equal to y, I can set them equal to each other. 2/3 x plus 3, I'm going to set that equal to 5x minus 2. And to start this one off, because I've got that fraction, I'm going to go ahead and clear my denominator. I'm going to multiply the whole equation by 3, all right, to cancel out that denominator. So 3 times 2/3, the 3's are just going to cancel, and so it's going to leave me with 2x. 3 times 3 will be 9, and I got to multiply the right side by 3 as well. 15x, and then 2 times 3 is 6. Okay, let's see, I need to move all my x's onto one side and my other numbers to the other. Let's go ahead. I'm going to move my 2x to the right-hand side, and I move my 6 to the left-hand side. So add 6 to both sides. All right, 2x's cancel, the 6's cancel. I'm left with 15 is equal to 13x, and then we'll divide by 13. So 15 divided by 13 is my x value. Okay, this is going to be the x value where they cross. Now, I think it'll probably be easier in this case if I go ahead and make this into a decimal. Let me see what 15 divided by 13 is as a decimal. 15 divided by 13, 1.15, we'll call it that. All right, so x is equal to 1.15. And then I'm going to take that answer and plug it back into one of these other two equations. I'll use that bottom equation again. So I'm going to have y equals 5 times 1.15 minus 2. That's going to be, what am I saying here? What is that? 5 times 1.15, that's going to be 5.65 or 5.75. Yeah, I think it's 5.75. All right, and then minus 2. So that's going to give me y is equal to 3.75. 6.75. All right. And so these two guys right here, those are going to be the XY pair where those two lines intersect. I could have plugged in 15 over 13 into the equation. It just would have given my answer as a fraction, but this is good enough. So the algebraic approach, it's handy when, well, like in this case, because they cross at non-whole numbers. So it would have been really hard to tell from just looking at the graph where exactly they cross. It'll also be handy for places where, like let's say they cross somewhere way far out, further than your graph can look. If you're doing it algebraically, that's not a problem. Okay,